So I would like to start today with an observation or reflection, or a couple of observations and reflections. The rituals of an inquiry-based class are very different from the rituals of a lecture-based class. These rituals have become more central as I think about my role as teacher, and they have become more central over the last decade, which is making me feel old, that I have more than a decade of doing this. And I now organize much of my role as a teacher around supporting my students as they engage in these rituals, whatever I mean by that, we'll define it soon, and helping them as they negotiate what these rituals actually should be. So the goals for today's session are to ground this observation in the research in undergraduate mathematics education literature a little bit, and connect that back to inquiry-based learning specifically, and then also to practice thinking through this lens, both see a couple of examples from me and then having you practice. That's why you needed to be in groups, because you're going to talk to each other. So some assumptions. I am a constructivist, which means several things, but today it'll mean that I think that humans are fundamentally active sense makers, that's sort of what the human mind is about, sort of, a little bit of cognitive dissonance, that means engage and try to make sense. And also that the way sense is made is by adding on to sort of existing structures or maybe modifying those structures. That's constructivist. But an extension of that, I am a social constructivist, so I didn't tell you what contexts the humans would make sense. I think they make sense of both internal sort of psychological contexts, like cognitive dissonance, but also external social phenomena. So that's sort of the perspective I'm bringing to bear on teaching. And so that brings us to the emergent perspective. This is the grounding in the room, research in undergraduate mathematics education literature. This term comes from Cobb and Yackel, two papers from 1996 that you should read. They're in my references at the end, so you get to see the information. But from them, the emergent perspective evolved from an initial psychological constructivist position. So originally, they thought more about just constructing in the psychological domain. But they wanted to account for students' mathematical development as it occurred in the social context of the classroom. So they felt the need to expand beyond just the psychological phenomena, to explain what they were seeing and to study what they were trying to understand. There's a chart that looks kind of like this. There'll be a different version of this chart on the next slide. But there's sort of two halves. There's a psychological half and a social half, or a sociological half. And each line, each sort of row in this is a pair of things that have some commonality. We'll talk more on the next slide. But what this really is a synthesis of a psychological constructivist perspective and a sociocultural perspective. So the psychological perspective, think Piaget. So you have access to new tools, or you're in a context where you don't understand what's going on, and the human mind developmentally would respond in particular kinds of ways, or maybe an older student would respond in a certain kinds of way, and their thinking, their perspective, the structures in their minds they would adapt them actively to make sense. The sociocultural perspective, it's a little bit more, there are sort of norms out in culture, and the way somebody learns is to internalize those and start participating in these larger norms. But the emergent perspective tries to coordinate these, and in particular puts them reflexively related to each other. So it's not that the social causes the psychological or the psychological causes the social, that they are reflexively related, that both are happening simultaneously at all times. And so this is basically how I'd like us to think about what's happening in the classroom. I might be blaspheming now, but if you'd like a metaphor, a puzzle metaphor. So from the psychological perspective, the social cultural. So the teacher, as the expert, has a puzzle, and the student's job is to build each individual piece and then reassemble the puzzle for themselves. That's their goal. From the psychological perspective, new pieces keep popping up, and then you put those pieces in. You maybe have to reorganize what's there to make a version of the puzzle as you're going. And the emergent perspective, the class as a whole has a puzzle they're working on, but then everyone sort of swaps out their piece for another piece that they've been working with and see if that makes a puzzle, and maybe they take their piece back and change it a little bit, reshape it, and they're constantly trying to figure out what puzzle they're making together, but out of pieces that they individually have access to. So puzzle metaphor, sorry if that was blasphemous, anyone. So an updated version of this perspective comes from Rasmussen, Waro, and Zanier. Rasmussen's in the room back there. So I hope I won't piss him off with this. So let's think a little bit more examples of what these things are. So the top row, classroom social norms and beliefs about roles or owned role, others' role, and nature of mathematical activity. So for example, you might think participation in the classroom. This doesn't have anything specifically to do with mathematics. So the classroom norm is what participation looks like, and then the psychological correlate is thoughts about what participation is and maybe why you would participate in that fashion. Socio-mathematical norms is probably the weirdest word on this slide. So Connolly defines the socio-mathematical norms as social norms that are specific to the discipline of mathematics. So for example, justification should be appropriate and acceptable, but it's not clear what that means, and it differs depending on the discipline. So the socio-mathematical norm would be, what does an appropriate justification look like in that classroom? And then the psychological correlate to that is beliefs, mathematical beliefs and values. Maybe epistemology, for example, for that example. What counts as an appropriate justification has something to do with what you believe is going on in terms of the development of mathematics. The bottom row, this is the expanded version of their perspective, has 4 instead of 2 things. Mathematical conceptions is the standard things, or how they understand the content and maybe how that changes through time. Participation, this is the individual participating, so what are they actually doing as an individual as they contribute. Classroom mathematical practices are the collective activities. So maybe in the class, you go through these rituals where you work an example and you articulate a conjecture and then you try to justify it, these sort of patterns of practices, behaviors that you do together. And those are for the classroom, but they might be related in some way, they probably are, to discipline and expert versions of those same, but the classroom ones don't have to be versions of the expert. They can just be what grows up in the classroom. And the goal of this perspective is to coordinate analyses, not to produce a taxonomy that says everything you see fits in exactly one of these categories and only one of these categories. This was helpful to me because I had been struggling with that for most of a year. You may also notice that the names changed. I don't know if this was significant, but it was social and psychological, and now this is actually an image from a paper. Now it's social and individual. I think if you think about their reflexivity, every one of these is simultaneously something psychological is happening and something social is happening. And so I like that shift, whether you're focusing on the individual or you're focusing on a group. But sort of both of them are happening all the time. So why am I talking about this at an IBL conference? So maybe sociocultural perspective would be a good fit for IBL. But the sociocultural perspective assumes sort of a transmission of expert rituals, right? That the teacher is a representative of mathematics and the students learn to mimic what the instructor did. Well, that transmission isn't a great fit, particularly in IBL classes where some of us actively resist modeling certain kinds of behaviors. So this is not a great fit for, as I see IBL. But the emergent perspective replaces that transmission with negotiation. So instead of the teacher says, here's what we ought to be doing, let's practice doing it, instead the group as a whole, the students and the teacher together collectively negotiate what those patterns are. And of course the teacher is influencing what those patterns are, maybe pushing them towards a disciplinary version, but it's negotiated live, which makes a lot more sense. This distinction might actually explain, some people are really concerned about whether or not students in an IBL class actually learn standard notation, right? And so this might be a version of the same concern, whether or not we're thinking of sort of transmission or negotiation. What about the psychological constructivist perspective? This perspective assumes that the social interactions are just triggers for psychological effects, but everything interesting is happening psychologically. But the emergent perspective replaces just this triggering with, I couldn't find a good word for this, episodes where both the psychological and social or sociological are happening simultaneously. And that makes a lot more sense than the way a lot of us talk about IBL. For example, it might explain the different roles of competition and collaboration in modern versions of IBL as compared to older versions, where it's very individualistic, and hence where I think the psychological perspective might have been a better fit for thinking about what was going on. So I do think that the emergent perspective is a good way for thinking about what's going on in an IBL classroom, and lots of researchers have actually done that, where we have these cognitive tasks, these psychological tasks, but they're engaged through communal effort. So they're mediated and their meaning is created by interacting with other people. So I'd like to show how I can use this idea to think a little about my classroom, and then we'll spend some time in some groups where you'll get to do the same, and then we'll share and see if we've learned some lessons. So this is a quote from Yackel and Cobb's '96 paper. A preliminary step in students' developing understanding of what constitutes an acceptable mathematical explanation is that they understand that the basis for their actions should be mathematical rather than status-based, right? That you use proof and evidence as appropriate as opposed to claiming authority. Does anyone else feel like this is one of the big goals that they're working on in their classes? Yeah, they're talking about second graders. So it's a little sad that we tried starting in second grade and we have not succeeded by junior year of college. But this is actually an important point because if these norms are continually being negotiated, then it actually makes sense that every year it would be the same goal, but it would have a slightly larger scope to it. So it's actually not as embarrassing as it could be. They were concerned that people would make decisions based on who had better erasers and who was smarter. So that doesn't happen in my class, but saying, well, I just learned it in high school, so it's true, it does happen. And so related to this, I'm interested in my students developing a proof scheme that's analytical. So Harrell and Sauter have sort of three big types of how students think they should justify arguments. There's external, which just relies on authority. Empirical, sort of proof by example, evidence, a lot more like science. And analytical, that's based on logical deduction. So my goal is that my students come out with an analytic proof scheme, and that they believe, that they understand why, and that corresponds with their beliefs about mathematical truth. So it's sort of epistemological, and it's also sort of proof process. So there's lots of different ways that this might play out in the framework. So we have an episode. Can you guys see the circles on that? OK. My students, very, very early in a junior level geometry course, constructed a bisector for an arbitrary angle. You have the angle. They got A and C prime to be the same distance away from the vertex. And then they drew two more circles around A and C prime to define the point D and drew the ray. And their proof was, well, the distances seem the same, so it's a bisector. And that was insufficient for me. And they knew, they were sheepish. They knew that they'd made a jump, but they had no idea how to move forward. So this is a transcript of the discussion after I said, no, that's not OK. OK, yep, they're congruent, but why? What results do we have whose conclusion is, therefore, these angles are congruent? Congruent triangles, which we call the congruent parts of congruent figures are congruent, which is one of our assumptions. That is the only result we have so far. It says, therefore, two angles are congruent, right? So that has to be our second to last step. So do you know any angles are congruent already? They shake their heads. You don't know anything about angles here. So what is our only other? And line segments. We're not going to get there just with line segments, right? We have three assumptions. We have axioms 1, 2, and 3. Axiom 1 says segments are congruent if their lengths are. But that's never going to get us figures being congruent, right? We have side, 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 and side, angle, side. What do you think, GV? Side, side, side. Can you put those two triangles inside, those two angles inside triangles that are congruent by side, side, side? Can you see those two angles as inside triangles that are congruent by side, side, side? Kind of, yeah, because the line BD is shared. The line made by the ray is shared. OK, so this is just an episode, and I'd like to think a little bit about what I see in it through these lenses. So my example for the first row was participation. Right? If you look at the transcript, basically every other utterance, it alternates. Every other utterance is me. And and what would that mean for them in terms of psychologically? I think it probably means they think that it's my responsibility to structure our discussion, their responsibility, but if you look at the content of their utterances, it's justifications. So I think they do have a sense of like how the role, like how the responsibilities are distributed in this kind of classroom. But me talking every other utterance was not what I wanted. It's early in the course, so I do scaffold a little bit more earlier in the course. And this particular cohort, I have taught this course 6 times. This particular cohort did can trick me into talking the most. They were pretty good at it. But that's something I see through this lens of like, what am I establishing? What are the patterns that I'm establishing here? This is the first real day of talking about mathematics, and this is how it went. And so I've, in some ways, may have communicated to them that what I wanted from our patterns of behaviors was this kind of back and forth didactic kind of thing. Now, it's not my ability to establish. I can't sort of declare this is what our patterns are, but this was a pretty powerful one, I think. 10 minutes left? Okay. And so cycles of participation. In terms of classroom practices, that you can see this habit where whenever we were thinking about an idea, I would ask a question like, what are all of the results that have this kind of flavor to them? What are all the results that have this conclusion to them? And I think that's a classroom mathematical practice because it's sort of a behavioral ritual they go through collectively, and they understand how they're supposed to engage with that, and that's part of the process of doing a proof. But sort of a related item, this is why I think it's important that it's not a taxonomy, that the same phenomenon can be explained, bleeds into different areas. There's definitely something there about what counts as a justification inside mathematics. So to make sure we have time for the active component, I've highlighted things where, this is where I said, what are our previous results? Much later in the term, they tried to construct a square. We did not yet have a parallel postulate, so it was not possible. During that work in class, I went over and drew a curved line to show them that they were making an assumption about something. And a student said, don't we assume that all lines are straight? And so this student knows that I prompted, but I didn't, not with words, that the thing they ought to be asking about is what we know and what we're assuming and what counts as a justification. And so we talk a lot about knowledge here. In the next episode, they say, oh, and when this happens, when we fail, what we have to do is make new assumptions. They're sort of aware of the malleable nature. And then there was an episode the next day where they had this assumption, but they were trying to actually finish constructing the square. And it ends with 45 seconds of silence, so I won't play you the video. But the student says, we know it has, and then he just sort of trails off. And I think it's really important. Maybe this is too surface a feature, but I think it's really important that they've picked up this language of knowing, right? What is known, what is not known, and that's where he gets stuck. He doesn't know what he knows. So I think this is evidence that he's internalized it, because I'm not prompting it. I'm not actually working with this group at all at this time. And I have some, that's very social, because it came from transcripts. I have some individual stuff, so this bottom reflection. It's interesting how different disciplines approach truth. For example, there are psychologists whom believe that statements are true until proven false. I'm not exactly sure where she got this idea. Just because I study math doesn't mean I follow mathematicians' means of defining universal truth. I'm still deciding whether I think about mathematical truth entirely through the lens of the mathematics discipline. But she's definitely wondering, like, ways of knowing, are they different across different disciplines? This is from an individual reflection. Okay, so we're going to take about 5 minutes to do our active activity. So at your tables, I would like you to discuss your reactions to this idea of an emergent perspective for thinking about your classroom. And if you need 2 more specific questions, how do you support students as they negotiate these patterns, norms, whichever version of the framework you're interested in the classroom? And what patterns do you actually think you're seeing in your classroom? How are they related to the cognitive work of your class and to the learning objectives that you've stated? So I'd like you to take a couple of minutes. I'm going to walk around, talk with the groups. We'll share a couple, and then we will conclude. So, any questions about the task? Go for it. Nah. If you guys would like, I forgot to give you my examples. So two things I say on my syllabus, which are not the same thing as establishing these norms, but are my ways of pushing them, are I convince them that we're going to be wrong together in class every day, and then I use that language repeatedly, so that's one of the patterns I see. I also pledge to make them as uncomfortable as I can every day in class, like it's a promise, it's on the text. Another one is, a slightly more subtle one, is that we always do an activity on the first day of class where they have to move around, stand up, and do other kinds of things to establish that part of what happens in this classroom is standing and moving is part of learning. So those are examples of things that you might do on purpose, or there might be other patterns that emerge that are not things that you're trying to make happen. That's what we're looking for. Well, we only have 2 or 3 minutes left, so would any table like to share an example of something they've been thinking about? Preferably one that they hadn't been thinking about consciously before, and now maybe they can?
So one of the things we were talking about was the art of facilitation. I call it art because you're involved with the students, at the same time you're outside the frame. So you try to probe them in their discussions. At the same time, look at the content of their discussion, make sure they're not going the wrong directions. And sometimes, like those examples you have, you need to be more involved. You need to talk a little bit more so they come back to the right content. That was one of the things we talked about.
Yeah, and the aspect of it that I overheard was whether you're inside or outside, which is, I know you're a math ed researcher, and so one of the things that shifts as you look at different cells in this table is which thing is considered the foreground, the thing you're interested in, which is the fixed background, and what you're inside. Are you inside the culture and that's invisible, or are you inside the classroom and that's stable and you're looking at the individual? Are you inside the individual and you're looking out? Yes. And we talk a lot at the IBL, in the IBL community about like how not to have students look at you while they're presenting and look at each other. But I think this is an interesting lens through which you think about it's sort of a norm in the classroom. So I just wanted to wrap up with one final connection from the original Yackel and Cobb paper. They were originally interested in developing students' autonomy, which for them started off as a psychological capacity that an individual would have, but they realized that it needed to be modified and changed into something more social. And so this is a collection of quotes from several pages. When students begin to consider the adequacy of an explanation for others rather than themselves, the explanation itself becomes the object of discourse. As students' understanding of an acceptable explanation evolves, they too may assume the role of teacher, judging what is acceptable, judging what is taken as shared by the community. However, it is the analysis of socio-mathematical norms implicit in the inquiry mathematics tradition that clarifies the process by which teachers foster the development of intellectual autonomy. The teacher guides the development of a community of validators and thus encourages the devolution of responsibility. So what they're claiming, and I think this is a very important point for us, is that it is not psychological expertise that then leads someone to be autonomous and creative afterwards. It comes through practicing these skills socially and understanding when to trigger a certain kind of behavior in the context. That's what leads to the kind of autonomy and originality and the other kinds of things that we talk so much about in this community. They're claiming, and I agree, that this comes because of the social negotiation. And I think that's really important for us to think about. And here are some papers. The one in red is the Rasmussen-Wara-Zanier paper, which is great. But the Yackel and Cobb and Yackel papers are also very good sources for these. And I'd love to chat if anybody wants to later.